Hello, kids. So I'm going to go over this worksheet. So I've already posted a PDF of this worksheet on Canvas. Okay. So right now I'm going to go over the more complicated naming ones. Excuse me, the more complicated naming ones, and I'm going to go over the formation of the ionic formulas part of it, which is questions 15 to 30. But for now, no, 16 through 30, I think. Right now, for these 1 through 15, I'm actually going to just do the more complicated ones. The simpler ones, you can just look at the PDF for the answers, okay? So I'll do any of the ones that have transition metals in them that require a Roman numeral in the actual name of it, okay? So starting with this compound. So you should be able to see my screen. I've split my screen so you can also see the common ion sheet over here. Um, okay, so this question is iron um, and nitrate, but we have to figure out what ion it is. Sorry, my scroll wasn't working, so I had to pause for a second. So we have iron and NO3 is nitrate, and you'll find that on the common ion sheet. So I just want to really tell you anything that you have been given is always either on the periodic table or it's in the common ion sheet. One of two places you can look, okay? There's nothing that you have to imagine for these names. So here is the common ion sheet, and on the common ion sheet you have nitrate right there. It has a -1 charge, so I know that this is iron, but I also know that there are two versions of iron. So until I figure out which iron it is, I just leave a blank space in parentheses, and I'm going to write iron nitrate. Okay, now let's figure out what iron it is. So iron has iron plus 2 and iron plus 3. So here's iron 2 and here's iron 3. You have to figure out which iron is present here. The way you figure that out is by looking at the charge of nitrate. Nitrate had a charge of -1. -1 times the 3 means that there are 3 nitrates here, and the 3 nitrates give you a -3 charge. So this is 3, 2, one ion. See, there's no subscript next to ion, which means there's only one ion. That means all of the charge to balance out the -3 must come from this one ion atom, which means this ion must be ion plus 3, which means this is going to be ion 3 nitrate. Okay, so that is how you figure out which transition metal is used. So let's do the next one, TiBr3. Titanium, again, is a transition metal. Anytime you find it in the transition metal section, you should check your common ion sheet. Titanium, there's titanium 2 and titanium 3. Okay, now I know that Br is bromide because bromine becomes bromide, okay? So titanium something bromide. And Br is actually -1 because bromine is in group 17, it's -1. -1 times 3 again gives me a -3. This is titanium, there's only one of them, 1 to 3 ratio. If this is -3, then this has to be +3. So this is titanium 3. Okay, the next one is CuP. So this is going to be copper. Copper something. Copper is a transition metal as well. So copper something, and then phosphorus becomes phosphide. So it's going to be copper phosphide. So let's figure out which copper it is. Phosphorus is in group 15 on your periodic tables. Group 15 elements have a -3 charge, and there is only one phosphorus, okay? And there are 3 coppers because there's Cu3 there, which indicates that something times 3 must give us a +3 to balance out the -3. So like let's say the number you're looking for is x, x times 3 must be +3. So the only number that will give you x times 3 equals +3 is if x is +1. plus 1 times 3 gives you plus 3. So this has to be copper 1, okay? Because it's only if you multiply plus 1 by 3 that you get a plus 3 to balance out the negative 3 from phosphorus. So copper 1 is what's present there. Okay. Next one is SnSe2. Sn is tin, transition metal. So parentheses. Then Se is selenide. Selenium is in group 16. And group 16 selenium has a negative 2 charge. Negative 2 times 2 gives me a negative 4. There is 2 seleniums for every 1 tin. That means that 1 tin must have enough positive charge to balance out the negative 4. That means that 1 tin is plus 4, which means that this is the tin you are looking for. Okay? Tin 4. So tin 4 right there. Okay? The next one is lead. Lead something. Lead is a transition metal as well. And SO4 is sulfate. There's sulfate right there. Make sure you find sulfate and not sulfite. Okay, SO4 is sulfate. The endings matter. Okay, sulfate has a charge of negative 2, as you can see. Negative 2 times 2 gives you negative 4. And there is only one lead here. This is a 1 to 2 ratio. That means all of the charge to balance out the negative 4 must come from that one lead. So that one lead must be plus 4, so it's lead 4. Okay, there is a lead 4 right there. Okay, then whoops, here's my document. Okay, now the next one is, let's do number 8 because the 7 is just beryllium bicarbonate. Again, if you're looking for the actual answers, there is a PDF with the answer key. Okay, we are looking for manganese. Mn is manganese. Manganese is a transition metal. And if you look at your common ion sheet, you'll notice that there is manganese 2 and manganese 3. So we have to figure out which manganese this is. And SO3 is sulfite. SO3 is sulfite. So this is just going to be sulfite, manganese something, sulfite. Sulfite, not sulfate. Be careful. So this is negative 2 because sulfite is negative 2. Negative 2 times 3 gives me a negative 6, which means something. I should use orange because I used green in the previous one. Negative 2 times 3 gives me negative 6. So something, x times 2 gives me plus 6. So what times 2 gives you plus 6? That's going to be a plus 3, right? There are only two possible um, things here. There is only manganese 2 and manganese 3. So there's a 50-50 chance it's one of them. And the only thing that can give you 3 times, the only thing that can give you something times 2 is equal to plus 6 is going to be plus 3. If it was plus 2, it will be 2 times 2 equals 4. That is incorrect, okay? You need a plus 6 to balance out the negative 6, so it has to be plus 3 right there. So this is manganese 3 sulfide, okay? Then the next one is gold hydroxide. So number 11, again, I'm skipping over the ones that are not transition metals. Check the PDF for the answers if you want all of them. Okay, so it's gold something hydroxide. There's gold 1 and there's gold 3. So there's a 50-50 chance it's one of them. And that is decided by the hydroxide. Hydroxide is negative 1. You can find hydroxide on your common ion sheet. Negative 1 times 3 gives me negative 3. There is 3 hydroxides for every 1 gold. So all the charge must come from the gold, which means it's a plus 3. The gold that has the plus 3 charge is gold 3. The Roman numeral and the charge are the same number. Okay, the Roman numeral gives you the charge. Ooh, this one is interesting. It looks complicated, but it is not. Okay, now there are 2 versions of mercury. Mercury 1 is weirdly Hg2 with a plus 2 charge. Mercury 2 Again, weirdly, it's just one Hg with a plus 2 charge. Okay, so we have to figure out which mercury this is. Mercury something, phosphate. PO4 is phosphate. Okay, now look at phosphate. Phosphate has a negative 3 charge. There's right there. Phosphate has a negative 3 charge. Negative 3 times 2 gives me negative 6. So something times 3, some number times 3 must give me a positive 6 because each phosphate is negative 3. Negative 3 times 2 gives me negative 6. X times 3 must equal plus 6. Okay? And the only number X can be based on the charges available for mercury, you can only have um, you can only have mercury plus 2 times 3 give you a plus 6. Okay, so this is mercury 2 in fact. There are two atoms of mercury per each mercury 1, so it can't be that. It has to be 3 individual atoms of mercury 2. So mercury 2 has a plus 2 charge. So this X has to be plus 2. Plus 2 times the 3 gives you a plus 6. So it's mercury 2. Okay. If it was mercury 1, this would not be the actual formula for this compound. Okay. Um, yeah, you wouldn't have a 3 there. Okay. So you have to be careful that you are looking at the correct mercury. It's this one. Okay. Now, I think that's it in terms of transition metals. Let's go to the next section, which is the formation of the actual anions. I mean, the actual formulas of the ionic compounds. Let me try to see if I can snap this screen. There. Okay, so let's do all of these 16 through 30 actually, because I think it's going to be valuable. So question 16 is chromium 2 phosphate. This is the amount of work that I actually expect from you to get 4 points on the test, okay? Chromium 2, the symbol is Cr. It's chromium 2, which indicates that it has a plus 2 charge. The Roman numeral indicates charge, okay? Sorry, kids, I've been talking all day. Okay, then phosphate is PO4 with a minus 3 charge. And you can find phosphate right here. Let me actually make this smaller because no one is looking at the screen. I'm not screen sharing right now. So there's phosphate right there. So you have a 2 and a 3. You need to cancel out those charges. So you need a least common multiple for all of these two numbers. So easiest way to see is if you multiply them with each other, what is the number you get? You get you get 6. 2 times 3 is 6, which means that's the common number that they have between each other. Okay, so 2 times the 3 gives you a plus 6, and 3 times the 2 gives you a minus 6. That means the plus 6 and minus 6 balance out and you got your compound. Okay, now the numbers inside the circles, those are our actual subscripts. So I was actually thinking of writing this slightly differently. So 2 times 3, see, now it looks like a subscript, and 3 times 2, those are your subscripts, which means your formula is CR3 parentheses PO4 close parentheses 2. That's your actual answer for this compound. Okay, now let's do the next one. The next one is tin 4 citrate. Again, like I said, the Roman numeral tells you what the charge is. So tin 4 has a plus 4 charge. It's right there. I've circled it already, okay? And then citrate's formula can be found here. Get rid of that. Here is citrate's formula right there. So citrate's formula is right there, which means you can just write citrate's formula C6H5O7 inside parentheses with a -3 charge. So 4 and a 3, the multiple or the number you are looking for is going to be 12, which is the highest you've worked with so far. So 4 times 3 gives you 12, and 3 times 4 gives you 12. I like this new way of writing the multiples because it looks like a subscript already. So you have SN 3 C6 H5O7 4. You got your compound. Okay, that's your answer for this question. Then the next one is lead 2 nitride. Lead 2 is Pb plus 2. Nitride is from your periodic table. IDE is group 15, 16, and 17. Those are the anions that end with ide. So nitride used to be nitrogen, which means it's -3 because group 15 elements have -3 charge. 2 and 3, again, we're looking for a 6. 2 times 3, 3 times 2. Anytime you have a 2 and a 3, the common number you're looking for is a 6. Okay, so this is going to be Pb3 and 2. Then the next one is iron 3. Iron is Fe. If it's iron 3, it's going to be a +3 charge. And then titanate is right here. So TiO3 inside parentheses with a -2 charge. Okay, now 3 and a 2 again. So 3 times 2. Then 2 times 3. You got your iron, Fe3, whoops, Fe2 Fe2 parentheses TiO3 with the 3. Don't get confused by the subscript inside the iron, okay? I mean, inside the titanate, the TiO3 is one unit in itself. You just need 3 of those units. You need 3 of the stuff inside the parentheses, which you're not allowed to change the formula of whatsoever. Okay? The next term is titanium 2 acetate. Titanium is +2. Acetate is C2H3O2 -1. So acetate can be found right here, okay? And then titanium 2 indicates it's got a charge of +2. So you have C2H3O2. You need to bring this up to a 2 to balance out the charges. So you have +2 and -2. So your compound is going to be Ti parentheses C2H3O2 close parentheses 2. You need 2 units of the acetate. All right? And you put boxes around these so you know that those are the actual final answers. The rest of it is all work, which is also very important and it's required on the test. Okay? Now, we got lead 4. Lead 4 means it's got a +4 charge. The Roman numeral tells you the charge. Sulfide ends in ide, found on the periodic table in group 16, -2 charge. We need 2 sulfides because you have a +4 charge. I need twice the amount of sulfide to balance out that +4. Okay, PbS2 is the compound. It's all a matter of balancing. Like if you were cooking and you added some salt, you need to also add vinegar to balance out that salt. So just like you are balancing out electrical charges, you can apply that to other things in your life. Okay, let's do chromium 3 hydroxide. Chromium 3 is Cr plus 3. Hydroxide is OH with a -1 charge. We are looking for a number to bring up the hydroxide to 3 times the amount to get a -3. So Cr plus 3 and -3 can cancel out. You have CrOH3. You need 3 times the amount of hydroxide to balance out that chromium because the chromium has such a high charge, you need more of the hydroxide. Okay, the next one is lithium iodide. This one is easy peasy. Lithium is group 1, so plus 1. Iodide is iodine from group 17, which is a minus 1. So plus 1 minus 1 balanced out. You got your answers, lithium iodide. Okay, next one is nickel 2 nitrite. Nickel 2 means got a plus 2 charge. And then nitrite is right here. Be very careful you don't mix it up with nitrate, which is ATE with the NO3. This one is NO2 with the minus 1 charge. Okay, then let's use purple. Okay, so we need twice the amount of nitrite because we got a plus 2 on the nickel and we got a minus 1 on the nitrite, which means we need minus 1 times 2, give us minus 2. So nickel 2 nitrite is going to look like that. Okay? Ni parentheses NO2 close parentheses 2. Don't get confused by the two similar subscripts right next to each other. NO2 is the nitrite unit. You need two of those units inside the parentheses to balance out. All right. Silver bromide, super easy. Ag plus 1, Br minus 1. Silver is a transition metal, but the charge can be found right here. Okay. Anytime you have a transition metal, just check this sheet. AgBr is your compound. And then this one I have to put a square around. Okay, zinc carbonate. Zinc is plus 2. You can find zinc right there. And carbonate is just CO3 with a minus 2 charge. Plus 2 minus 2 cancel out. You got your zinc carbonate. That's it. Okay. Gold 3 dichromate. Gold is Au. Gold 3 is plus 3. Then dichromate is Cr2O7 with a minus 2 charge. We have our 3 and 2 pattern again. So 3 times 2 and then 2 times 3 to get a plus 6 and a minus 6. So you need 2 atoms of gold, Au2 CRO, CR2O7. You need 3 of this. This is very large. So you need 3 units of the dichromate and you need 2 units of gold. So you need twice the amount of gold that you currently have and you need 3 times the amount of dichromate that you started out with. Okay? Then the next one is copper 2 chlorate. So that is going to be copper with a plus 2 charge because copper 2, and then chlorate is just ClO3 minus 1, which means you need 2 chlorates because I need to bring this up to a negative 2 because I have a plus 2 here. Negative 1 times 2 is going to be negative 2 here. Okay, so that's going to be Cu ClO3 close parentheses 2. The multiple becomes the subscript over here. Okay, then manganese 3 chromate. Manganese 3 is going to be plus 3 because manganese 3. And then chromate is just CrO4 with a negative 2 charge. Again, see what I mean? You got the negative 2, you got a plus 3 and the negative 2. So a 3 and a 2 situation again, it's going to be 3 times the 2. It's going to be 2 times the 3. Okay? Then you can write Mn 2 parentheses CrO4 3 on the outside. Don't get confused by the fact that there's a 4 and a 3 next to each other. CrO4 is chromate. You need 3 times the amount of chromate to balance out the charges. Okay? Then, last one is ammonium oxide. Ammonium is just NH4 with a plus 1 charge. It's the only polyatomic cation right there. And then oxide means it's oxygen from group 16, negative 2. So you have a negative 2 here and a plus 1, which means I must multiply my ammonium by 2. I need twice the amount of ammonium. So that's going to be NH4 2 because that's the multiple. Oh, okay, I know it looks weird, but that's the correct formula for the compound. Okay, so those are your answers and the methodology to do formula writing. Just as a refresher to your brain, hopefully this will help you guys just get back to um, balancing charges and getting used to balancing charges. So again, the gaps left here, you can find those answers on